Okay, so this next lesson is to, what we're going to work with is recognizing what like terms are and then adding like terms together. By the way, Tuesday of next week, I think, maybe Thursday. Tuesday or Thursday of next week, I have you set up for a map test.
Okay.
And you'll have one more test in before Christmas break.
So two tests. And before 25th, and
One more test. Oh, the map test. The map test is that one you do on the computer. M-A-P, not M-A-T-H. But this lesson, what we want to talk about is recognizing what like terms are, and then how do I add like terms together. So the first thing we need to do is understand what are like terms. So to talk, well, back up, what were terms? What did we say terms were?
numbers. Letters.
Can be. Can be.
Awesome.
Can be. Anything pretty much between plus or minus signs. It's going to be a collection or a group of factors. It's going to be a quotient. If you talk about the quotient, so you can have a fraction is going to be a term. Those are things we dealt with in the last assignment. If we look down here at the very bottom of the screen, we have 4xmp minus 2pmx plus 6mxp. How many terms are there?
There are three. No, four. Three.
Three. 4xmp is one, negative 2, pmx is another one, and plus 6mxp is the third one. So there's three terms. So like variables, terms that have the same variables in the same form or in equivalent forms, so that the terms, excluding the numerical coefficient, I don't want to look at the number part, I'm looking at the literal coefficient, we're looking at variables, represent the same number regardless of the non-zero values assigned to the variables. So if I were to look at this for an example, we have 4xmp minus 2 pmx plus 6 mxp. If I told you x was equal to 1, m was equal to 2, and p was equal to 3, I could say that this first term is the same thing as 4 times what number? 1 times 2 times 3 is 6. And this next part would be minus 2 times, if I take 3 times 2 times 1, you get 6. And if I look at the last term, it would be 6 times, 2 times 1 is 2 times 3 is 6. They all have this 6 in common. The only difference is this number in front, which is the 4, which starts out as the numerical coefficient. So we have 4. Okay, come on, computer. Just a moment, my computer is not telling, it's not doing what I'm telling it to do. Yeah, I don't know what it's doing. I never did touch any of that stuff. Oh no.
My dad's computer was having a.
Okay, I'll pause this until I get it fixed. All right, hopefully we're back functioning now. So the only difference is that numerical coefficient of the first term is 4. The numerical coefficient of the second term is 2. And the numerical coefficient of the third term is 6. Now, if I were to calculate this, what is 6 times 4? 24. 2 times 6? 12. And 6 times 6 is 36. So if I calculate this, what do you get for an answer?
You're going to get 48.
You're going to get 48. Very good. Now, if I were to look at this particular problem and talk about grouping or adding like terms together, I would consider all three of these to be like terms because they all have the variables p, m, and x all to the first power. So all three of these are the same except for the commutative property of multiplication, which changes the order of them, but that's allowed. When you are grouping them together, we work with just the numerical coefficients. So I have a positive 4. I have a negative 2. Take the sign in front of it. And I have a positive 6. What happens when I group those together? What is 4 minus 2? 2 plus 6 is 8. So I could add these together and get 8 mxp. If I go back and calculate it where x is 1, m is 2, and p is 3, that's going to be 8 times 6, and the answer is 48. Is that the same thing that we got by sitting there and putting the numbers in and finding out what is the value of every single term? It is. They have to be like terms, though. And what we want to work with today is being able to recognize those like terms and then group them together or add them together. How do we add like terms? Did I do anything different with the mxp when we grouped it together? Nope, right there. All we did is add the coefficients. The variables remained as m, x, and p in my final answer. So here's what we want to do. First of all, we are going to look at this top expression, and we know that we can do something with that expression, which is the distributive property. What do you get when you use the distributive property?
You can change it around in the between.
Yeah, if I were to take 4 times all of this right here, that would be like taking the 4 and carrying it through to each one of those, right? So we would end up with 4x plus 4p plus 4dy. That's equivalent. Are those like terms? How are they like? The force. But when we talk about like terms, we want to exclude the numerical coefficient. And the only thing that we want to look at is the variables. That's the key thing that we're looking at. So if we come back to this, are they like terms? No, because the variables are not the same. Variables are not the same. If I were to work through this problem and do the distributive property, what are you going to end up with? But we like the numerical coefficient first, so we'll say it's 4xmp. Now, are those like terms? Yes, they are like terms, and this is why. Because if I look at this first term, I have an x to the first, m to the first, p to the first. Do I have the same thing here? Yes. And do I have the same thing here? Yes. So if those are the same, I can go ahead and just work with the calculation, the addition and subtraction of the numerical coefficients. What is 4 minus 2? 2 plus 6? 8. So this is 8xmp. That means the same thing. If I come back to my original question right here, or the original problem, and if I were to forget about the distributive property, and I said, let's solve inside parentheses first. If I solved inside the parentheses first, I would have xmp times one side the parentheses. 4 minus 2 is 2, plus 6 is 8. I get something that looks like that. Then what happens if you multiply that together?
8.
You get 8xmp. That's why you can do it. It's like you're factoring out those common factors, which are the variables. And it has to be in every single one. Oh, down below, I guess I just showed you right here. This is what you get when you multiply it out. And those are like terms. So you work with those coefficients. Are you taking a screenshot? Did you get it? So here's how we do it. To add like terms, we algebraically add the numerical coefficients of the like terms. If I glance at this right here, I have the same thing depicted down below with circles. 3x. What color is represented with 3x? Nope. The green. So I'm going to line these up kind of the way that, oh no, that's not what I want. Okay, maybe this isn't gonna work. So I'm gonna line up my 3x. So there's my 3x. The next thing it has is plus 5. Well, that's gonna be this right here, right? Then I have minus xy. That coefficient there is understood to be a 1. So we need to look at it as if there's a 1 right here. Are you okay with that?
Yeah.
All right. The next thing that we have is 2xy, which I have 2 of them right here. And the last thing we have is minus 5x. Now, which one of these, out of all of these, which ones are like terms? Can you determine which one of those are like terms? As I look at it, the like terms, did you notice that I did something with the size of the circles as well? Yeah, but what do you notice about the green ones right here and the red ones?
They're smaller.
No.
But if I were to take one of these, what do you notice about the size of them?
Well, they are the same.
They are the exact same size. So what happens if I wanted to, I could group together, right? I'm going to start grouping all of these together, and what are you going to be left with? Well, what's happening to these two right here? These are going to cancel out, right? And these cancel out. And these cancel out. And what you were left with is you were just left with these two right here. Yes, I also noticed that, glancing at this, these two terms are exactly the same. They're the same not because when I represent them with the circles, those circles have the exact same size. So, oh, come on. Those circles have the exact same size, but they, oops, supposed to. Sorry, I'm trying to keep this as close as possible. But the reason that I can go ahead and cancel them is because they are like terms. They are like terms because the variables xy, both to the first power, occur in both of them. So that didn't work. So these two cancel out, right? A positive and a negative cancel out. So my answer, what am I left with here?
You're negative 9, x, x, y, and 5.
I'm left with an xy. I am left with a negative 2x and a positive 5. Well, guess what happens? If I come up here and I work through this problem, I glance and I say, well, 3x and negative 5x. Like terms. What are your coefficients? 3 and negative 5. What is 3 minus 5? Negative 2x. Right there. Did the variable disappear?
No.
No, it remains with it. If I look at the next one, I had this 5. It's by itself. It's right there, which comes right there. Nope, there sure doesn't.
5 minus 2x.
And if I look at these two terms, they are like terms. So I have a negative 1 and a positive 2. That groups together to just give you 1. It does not matter the order. Normally, if I'm going through, I take my problem and I start with the very first one. And I would just highlight or I would circle or something like terms. So 3x and negative 5x is going to leave me with negative 2x. And then I have a positive 5. And then these two terms are like terms, which leave you with positive xy. And that's what I would write as my answer. The order does not matter. Why? What property?
Distributive.
Not distributive. Commutative property of addition. A commutative property of addition. So I have 2 problems up on the board. Would you please work through those by grouping like terms together? Simplify by adding like terms. That's what the question is. Simplify by adding like terms. I will give you 2 minutes. Go. Okay. So the first problem. The first term is xy. The variables are xy. Is the second term a like term?
No.
Why?
Because it has a z.
No, because it has a z. Is the next term a like term?
Yes.
Yes, because it has x and y to the same power. Is the last term a like term? Okay, we'll go to the second term, which is XYZ, and the last term is XYZ. So now we work with the coefficients, and if we work with the coefficients, 3 minus 10 is negative 7XY, and then I have positive 2 and negative 5 is
Negative 3, XYZ. I almost got that right.
That is correct. That is your first answer. Be careful of the signs. Some people want to put this second term right here. They want to put it as a positive because that's the first sign that they see. But it's not. You have to positive or negative based off of the grouping of your terms. So if I look at the second problem, just because I don't want to switch. We have 4. What's another like term with 4? 5. I'm going to take the sign in front of it and negative 15. So I can group those together. What is 4 plus 5? 9 minus 15 is negative 6. Now I'm going to work through the second term, which is positive 7mxy. Is that 1, 2, 3, fourth term a like term? Yes, because it has the variables x and y again, or mxy. That gives you 10 mxy. And there's your solution. You're not ruining my marker, are you?
No, I'm just erasing it off.
Oh, you got the cap on it.
Yeah.
I'll give you a washcloth. So you don't scratch the desk. I don't know if that scratches the desk.
All right. All right.
Okay, that's okay. You have 2 more. Go ahead and work through these 2. So I forgot to record all of that. I'll just let you look there at your answers real quick. Don't forget what's in purple up at the top there. The 3x and the negative 3x are additive inverses, so they cancel each other out. Okay, so you have your answers. You can pause that and look at it if you need to when you go back and watch the video. Okay, so here's the next 2, and I'll pause and hopefully not forget to start here.
I would actually be more than
A question that has come up, if on this bottom one we happen to have a z there, these are all like terms because they're x, y, and z, and you would have 2 plus 3 is 5 minus 5. Your answer is just 0. Don't think that the coefficients are 0, so then I get an x, y, z, and I don't put a number down. That's understood to be 1 x, y, z. So you can't just leave it as x, y, z. It's 0 x, y, z, and 0 times anything is 0, and your answer would be 0. Okay, but I'm going to go back and erase this and then pause it, and then maybe Bladen's going to come up. Is that right?
Yeah, I'll be more than happy to.
Would you want to right now and do the first problem before I even pause it?
Yeah, it's fine.
Okay, I'll let you work through it. Okay, maybe I will pause it. No? Oh, wait, I got that. You're writing it that way. Oh, you have to take the sign in front of it. Here's your problem right there. Take the sign in front of it.
Okay, so what you gotta do, negative 2xy minus 4yx, and you get
Negative 6.
good job. Okay, so
Erase what you've got. Here, I'll erase it for you.
yeah, because I don't know how to, Eric.
It's okay. We got it. Okay, so what do you get when you group those two together?
And negative
Negative
6
6
That's why.
x,
xy.
yeah, xy. Okay, and so now you want to do 3 minus 2x is
What a max does that need to do with x? Is that negative plus x?
just x, just x. So what do you do? What do you put here? Plus x. Good job. Okay. Yeah, and then we just put 4. Plus 4. There we go.
I got you.
There you go.
All right.
Well, because what are you gonna care?
Alright,
so 2x, y, z. Yeah. minus that s, negative 3x y z, and z plus this.
Again, the first and the last term are like terms because they have the same variables, x, y, z raised to the first power. Eric, you want to do another one? Or you want to do one? Do you guys need more examples or you? Eric's gonna do the top one.
Okay, so first you gotta do this and this.
Those are like terms?
We were close.
Alright, so you add this to this, that gives you 9 y, c. Then you do this, which gives you negative 2 c.
Very good. My turn?
But,
Wait, yeah, wait.
okay, so well, I got one.
Okay.
Hey, press the black button on it. Oh, got him.
Okay, so what we're gonna start out doing is put our 4. Okay. Okay, yeah. So minus.
Second term is circle it, negative x. You gotta take the sign, no, take the sign with it. There you go, negative x. Where's the other like term? Circle the other like term.
What's plus?
What is it?
Yes, it is. You have to take the sign with it.
Yes, it is.
Wait, it's not.
So what is negative x plus 3x? Negative 1 plus 3.
Positive 2x.
Okay, so then put plus 2x.
Yo.
Okay, just a moment. I'm going to do something here.
And then it'd be minus. It'd be minus.
Wait, it's not based off of the sign that's there. Don't go based off of this sign right here. What you have to do, Bladen, is you have to take the sign with it. It will end up being a minus, but don't do it just because the sign right there is a negative. Now, what's negative 2 and negative 7? Negative 2 and negative 7 is
Negative 9.
negative 9. Put a 9 there instead of a 5. There you go. My tips come up. Okay, are you guys good to go? Okay, I'm going to save this